Hi everyone, today we are going to learn about how to define general angles and how to draw them on a coordinate plane in standard position, as well as how to use radian measure and how it relates to angles on a coordinate plane. But before we get started, I would like you to go ahead and do this warm-up. And for this warm-up, I would like you to please go ahead and draw a right triangle in which the opposite leg to an angle that we're going to call theta is 15 units. The adjacent leg is 20 units, and the hypotenuse is 25 units. Once you've drawn your picture, I want you to then identify all 6 trigonometric ratios for your angle being theta. So go ahead and pause the video and try this warm-up on your own. We did a lot of them in the first lesson, so hopefully this is very easy for you, but I want to make sure that you genuinely know how to solve a problem like this. So go ahead and pause the video and try this on your own. All right, let's go ahead and see how well you did. So hopefully you were able to draw a right triangle. So I'm going to draw my right triangle like this. And I'm going to make a right angle. And you can put your theta up top or on the bottom. Whatever you chose to do is perfectly fine. I'm going to put my theta down here. And my opposite leg is 15. My adjacent leg is 20. And my hypotenuse is 25. Then we want to define all 6 trigonometric ratios. So sine of theta, that is going to be equal to the opposite over hypotenuse. So the opposite in this case is 15, and the hypotenuse is 25. So 15 over 25. All of these fractions, if they can be simplified, I expect you to simplify them. And since both 15 and 25 are divisible by 5, you should have ended up with 3/5 as your answer. Next, we have cosine. And the cosine of theta, that is going to be equal to the adjacent, in this case is 20, divided by the hypotenuse, which is 25. Both of those numbers are divisible by 5, and you'll end up with 4/5 as your answer. Then we have tangent. Tangent of theta, that's equal to the opposite over the adjacent, which is 15 over 20. Both of these are divisible by 5, and you'll end up with 3/4 as your answer. Now, in order to identify the inverse functions, we have cosecant of theta. That is going to be the inverse of what you found sine to be. And since sine ended up being 3/5, the reciprocal, not just inverse, the reciprocal of 3/5 is 5/3. And there's your answer for cosecant of theta. The secant of theta is the reciprocal for cosine, and the reciprocal of 4/5 is 5/4. And cotangent of theta, that is the reciprocal of tangent, and the reciprocal of 3/4 is 4/3. So there really wasn't a lot of work to show in that problem. Hopefully you got that one correct, and that was very easy for you. So now we're going to go ahead and get started by talking about how to graph angles onto a coordinate plane. Now in the first lesson, 13.1, we only worked with acute angles. But in this lesson, we're going to be learning about angles with measures that can be any of the real numbers that are out there. So we're going to be working with a lot of different types of numbers today. Like I said to you before, we're going to be learning about how to draw angles or sketch angles onto a coordinate plane. And every angle has an initial side and a terminal side. So I have here, an angle can be formed by fixing one ray. So know that all angles are formed by 2 rays where they meet at a vertex. So you can fix one ray on the initial side and rotating the other ray, called the terminal side, about the vertex. So that's very fancy for what you see here. In this picture, we have ourselves an angle. And in this angle, we have ourselves our initial side, and the initial side is always going to be on the positive axis, and the vertex in standard position is what we call this. The vertex is always going to be at the origin, or at 0, 0. So that's what our next blank is. It says the standard position of this angle. So the position of an angle whose vertex is at the origin and whose initial side lies on the positive x-axis. So that's what we have here in this picture. We have our initial side lying on our positive x-axis, and then our angle, or our other side, is rotated back, and then it finally ends or lands at some spot. And that's what we call the terminal side. And the reason why I have my arrow pointing backwards is because that's how the angle was rotated. It's also possible that the angle could be rotated the other way. So if the angle is rotated counterclockwise, so CCW means counterclockwise, then what we have is a positive angle. And if your angle was, or your terminal side was being rotated in the opposite direction, or in clockwise motion, then we would have a negative angle. So positive angles and negative angles depend on where is the angle landing, where are you rotating it? Are you rotating it counterclockwise or clockwise? And so that's what we're going to be practicing here in example number 1, drawing angles in standard position. So a few things to note. 360 degrees represents one full circle or one full revolution. So what I would strongly recommend going all the way around your axes for every single one of these, since we're talking about angles or degrees, is I would label. And I'm going to be looking for you to have labels on all of your axes. So we're going to start with 0 degrees. And every single time we hit an axis, we're traveling 90 degrees. So I'm traveling 90 degrees, and then I'm going to travel another 90 degrees to get 180 degrees. Then I'm going to travel another 90 degrees to get 270 degrees. Then I'm going to travel another 90 degrees to land at 360 degrees. So for letter A, we're looking at 405 degrees. So let's go ahead and figure out how far away 405 degrees is from 360. Clearly, it's a lot bigger than 360, but by how much? Well, the one approach is to take 405 and subtract 360. And when you take 405 and you subtract 360, you will be left with 45 degrees. So what this really means for letter A is that 405 degrees, which is what I'm going to be doing right here, is 405 degrees. That's letter A. 405 degrees is really 360 degrees plus another 45 degrees. So the way that you draw it is, since we're going in a positive motion, is I'm going to draw my initial side. I'm going to put a little arrow at the end since this is an angle. And I'm going to rotate my angle 360. And then I'm going to travel 45 degrees, which is about halfway between 0 and 90. So going about halfway, I'm going to draw like a little arrow and then an angle coming out of it. And this whole spin right here represents 405 degrees because we travel 360 plus 45 degrees more. So I've just drawn 405 degrees. Let's go ahead and look at letter B. For letter B, we're talking about negative 65 degrees. So that negative tells me I'm going to be traveling in a clockwise motion. So when you label your axes, you want to label using negative degrees. I'm still going to start with 0 degrees, but now moving in a clockwise motion, this represents negative 90 degrees, negative 180 degrees. Up here will be negative 270 degrees, and back around, this is negative 360 degrees. So negative 65 degrees, well, that's going to be a little bit closer to negative 90 than 45 was to 90, so it's just going to be a little bit closer. So I'm going to draw my initial side on the positive x-axis, and then I'm going to kind of guesstimate. This is not going to be perfect, but it's a little bit more than halfway, and this represents negative 65 degrees. I'm going to be looking for, when you are doing these types of problems on your test, because there will be problems exactly like this on your test, I will be looking for a couple of things. First, I'm going to be looking for labels. Did you label your axes? Next, I'm going to be looking for, did you draw your initial side? Because a lot of times kids don't want to draw the initial side for some odd reason. And when you drew your terminal side, did you draw an arrow? That arrow tells me that you understand the direction in which you are traveling. The arrow tells me that you understand which direction is negative and which direction is positive. So that is what I'm going to be looking for when you do problems like these on your test. All right, I want you to go ahead and pause the video and try letter C and letter D on your own. And then once you have an answer for C and D, go ahead and restart the video and we'll see how well you did. All right, let's check it out. So for letter C, we are looking at 240 degrees. So that's positive. So I'm going to label my axes 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now, 240 degrees, that's 60 degrees beyond 180. So I'm going to draw my initial side, and I'm going to go in a counterclockwise motion, and I'm going to stop right around here. So it's a little bit past halfway between 180 to 270. And this represents 240 degrees. So hopefully your picture is pretty close to my picture. This is a sketch, a guesstimation, so it should be pretty close, just a little bit beyond halfway between 180 and 270. And that would be a pretty accurate picture. For letter D, we have negative 150 degrees. So that means that you should have labeled your axes using negative degrees. So I have 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. Now, negative 150 is going to be located about 30 degrees away from negative 180. So I'm going to draw my initial side, and I'm going to go in a clockwise motion back about right here, more than halfway for sure. And this represents negative 150 degrees. So hopefully you found this concept to be pretty easy, because now we're going to take it to another level. Now, just because this angle right here represents negative 150 degrees does not mean that that's like the only angle that this angle could represent. We could have also gone in a clockwise or a counterclockwise motion, a positive motion, and ended up in the same exact spot. Same thing for all of the other angles. This angle right here, we could have gone clockwise and ended up in the same exact spot, only having a negative angle in that same position. And so anytime that you have angles where the terminal side ends in the exact same position, so angles that are in standard position in which the terminal sides are exactly the same, we call that coincide. Those are called coterminal angles. So there exists an infinite amount of angles that could land at the exact same spot as all of the other angles that we just drew up here. So what we want to do for example number 2 is we want to draw an angle with a given measure in standard position. So whatever angle I gave you, I want you to draw it. Then I want you to identify one positive coterminal angle and one negative coterminal angle. Now, there does exist a trick, and this trick sometimes works but does not always work. But the trick is that take whatever angle that is given to you and either add 360 degrees or subtract 360 degrees. But not just 360 degrees, you could also work with multiples of 360 degrees, and that's what we're going to deal with in letter A. And what I mean by multiples of 360 degrees, meaning 360 degrees or 720 degrees, etc., etc. So for letter A, let's first go ahead and start off by graphing 485 degrees. Well, 485 degrees is clearly a lot bigger than 360. So let's go ahead and figure out how much bigger 485 degrees is from 360. So I'm going to take 485 and I'm going to subtract 360 from it. And 485 minus 360 is 125 degrees. So 125 degrees, I know how to graph that. So I have a good idea about where that's going to be. So I'm going to label my graph using, or my grid using degrees. Here's 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And I'm going to graph 125 degrees. I'm going to graph 125 degrees. Because I at least know where that's going to be. It's going to be a little bit closer to 90 degrees than 180 degrees. So I'm just going to say that it's about right here, going backwards. So it's about right there. But unfortunately, that's not what was asked of me. Even though I did graph 125 degrees, I'm looking for 485. So that really means 360 degrees plus an additional 125 degrees. So really and truly, my answer, I'm just going to use a color, my true answer is this one in black. So that is me drawing the initial angle. But I was asked to find two angles that coincide, one that's positive and one that's negative. So the angle that is positive that coincides with 485, meaning it lands in the same position, is 125 degrees. 125 degrees is what we call a coterminal angle because it lands in the same exact position. So I'm just going to use green in order to identify that. Now what I need to do is I need to find a negative coterminal angle. So I'm going to subtract, I'm going to take 485, and instead of subtracting just one 360 degrees, I'm going to subtract two 360 degree angles. So I'm going to take 485 and I'm going to subtract 2 times 360 because remember my goal is to come up with a negative coterminal angle. So this is 485 minus 720 and that's going to be equal to negative 235 degrees. So negative 235 degrees will lie in the same exact position as 485. So I'm going to go backwards and this angle right here is negative 235 degrees. So I just identified two coterminal angles, one that's negative and one that's positive. And that's what you're going to be doing for all of these problems. So let's go ahead and look at letter B. So for letter B, we have negative 75 degrees. So I'm going to graph negative 75 degrees first. Fortunately, negative 75 degrees is not that bad to graph. It's not like 485 where you have to get all complicated with it. So I'm going to plot 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. So negative 75 degrees is a little bit closer to 90 degrees than halfway. So I'm going to draw my initial side, and I'm going to draw like an arrow where it's pretty close to 90 degrees, but not quite there, about maybe 15 degrees away. And here is my sketch of negative 75 degrees. So this is negative 75 degrees. So there's my first sketch. Next, what I need to do is I need to come up with a positive coterminal angle and a negative coterminal angle. So what I'm going to start off by doing is I'm going to take negative 75 degrees and I'm going to add 360 to it. So negative 75 plus 360, that is equal to 285 degrees. So that means that there's my positive. So I just added 360 degrees to that. So that means that if I were to go in a counterclockwise motion, I would travel 285 degrees. That's how far I would go, about 285 degrees. That's where this is. So now what I'm going to do is I'm going to take negative 75 degrees, and instead of adding, I'm going to subtract 360 degrees. And when I do that, I end up with negative 435 degrees. So the way to draw that is we're going to go in a negative motion. So we're going to go around the circle one full time, going in clockwise motion. So I went around one full 360 degrees, and then I'm going to go around just a little bit more, and this negative direction indicates that we just traveled negative 435 degrees. And that is our answer. So those are our two coterminal angles. All a coterminal angle is another angle that lands in the exact same position as the original angle. That's all that a coterminal angle actually is. And the negative positive just represents the direction in which the angle is traveling. That is all. So now we're going to move on to another thing called radian measure. So for radians, a radian of a circle, actually, ladies and gentlemen, I'm going to pause. I'm going to stop the video right here, and I'm going to create another video. So I'm going to pause the video right here, and then so we just finished with working with degrees, and then I'm going to post another video for you guys for radian measure. So I just wanted to give you that heads up. I'm going to stop the video at this time.